this is the Sonata board. So on here you've got an RP 2040, which is just sort of managing everything. There's an FPGA where the processor is kept, so that loads bit files, and then there's some memory to run apps as well. You can actually store multiple bit files, which you select with this little switch labeled bitstream over here, which is SW3 bitstream, and you can store multiple apps, which you select with this one down here. It has 3 options there as well, 1, 2 and 3. And that's the SW app switch, which is SW7. Put them both on 1, so we'll have app 1, we'll have bitstream 1. So in theory you could have different versions of the processor running. We've not plugged it in yet, but the power there is going to one labeled main USB, which is J2. There's a few other bits you'll see later. There's some LEDs over there, and there's some user LEDs here, and some user switches, and then there's also some capability exception LEDs to actually what capability you're getting. There's the reset button here, and this one we're going to use to put it in the bootloader mode for the RP 2040. So that's going to be one of the first things we do. So moving back to the screen, the first thing we need to do is go to the releases. Here they are. Yeah, scroll down these. We were looking for, well, I'm doing version 1. I don't want the pre-release because it's not quite there yet. Sonata system version 1. Scroll down and grab these files, not the source code. That's the RP 2040 firmware. These is the bit file for slot 1, slot 2 or slot 3. Remember we had 3 slots for the bit stream. Yeah. And some demos. So there's a Snake demo for slot 2 and there's a Sonata simple demo for slot 1. So we could actually have both of them in here if we wanted to. Okay, so I've downloaded all of those and they are in my downloads folder from yesterday. Yeah, I've got my Ubuntu folder open for later. I've got the device manager because we're going to use that later, and I've got just an Explorer down here. So the first thing we need to do is update the firmware on the Raspberry Pi, well, the RP 2040. So we hold down switch 9, which is the RP 2040 boot. I'm just going to hold that button in with my finger, and I'm going to plug the USB 3 in, and we should see a new drive appeared called RPi RP 20 and a million things offered to try and back it up, but let's have a look. Here it is, and if we click on it, there's nothing in there. So updating the firmware is simply a case of dragging it across. I use the right mouse so I can choose whether I'm copying or moving. At which point it will automatically reboot, it disconnects, and then it will reconnect as Sonata. Now if you don't hold the button down, that's what you'll normally get anyway. So if you just plug it in normally without holding the button down, and it's gone straight into running some test code there, which was obviously on this one. So some interesting things to note if you look at the device manager here. You've got some USB serial ports of some description have turned up. There's 3 of them. Now it's finally installed them. So it's COM 8, 9 and 10. We'll come back to those later. One of them is the debug port, and I haven't bothered with the other ones. So now if we open Windows Explorer again, we should have the Sonata drive. So normally if you just plug it in, that's what you get. So if we want to update the bit files, so that's the configuration for that matches the bitstream selector. So this is the hardware configuration. So this is the actual processor. So let's update the one in slot 1. Yeah, like this. And it will update it to version 1.1. I don't know what version's already on here. I was sent this by somebody else. I will, now we see the screen's gone blank. Yeah. Interesting. And we've got the legacy light is off and the CHERI light is on. FPGA config, it reboots automatically. I won't update slot 2. What we can do now though is we can update the Sonata simple demo on slot 1. So let's drag that baby in there, and it should just run that demo, which is a set of lights. Yeah. Running on Sonata, protected by CHERI. Yeah. Now the Snake demo is on slot 2. Remember, we've got bitstream slots and app slots. So this is we put the bitstream on slot 1, and we've put the first demo on slot 2. So on slot 1 of the app. So let's put the Snake demo, which is on slot 2. Let's just copy that across as well. Now obviously it's going to go back to running the other one. If we now change the software app to slot 2, like that, and then hit reboot, we should get the Snake game. Move the joystick to start, and then we have Snake running. I died because it's not the right way up. So that's the basics of using it and programming it, or loading things. No, reset. Let's try again. Come on, brain. Yeah, and there's some cherries. Of course, it's CHERI based, isn't it? Yeah, and this is why I program, not play games for a living. That's the basics. Nice and simple. Now, if I choose something that hasn't got some code in, so as far as I know, slot 3 doesn't have anything in, we may get an error. So let's put it on slot 3 of the software app and hit reset. What happens? Doesn't seem to see anything there. Just blank. Yeah. If we get something where we're outside a boundary, for example, then the specific exception, capability exception that you have, it will come up here. The most common ones are bounds, i.e. you've just finished executing the code and it's carried on trying to run off. And sometimes the tag one is if you've run out of stack, you see the tag one quite frequently. Anyway, that's the basics. It's not that complicated. So next we want to see what's happening on the serial ports for debugging purposes. So we have the unit here. When we plug it in, if we look at Device Manager over here, I've opened the ports, common LPT. You'll see when we plug it in, we should get small ports appear. Give it a second, it will refresh. There we go. So we've got 8, 9, and 10. I can never remember which of these it is. I think it's the middle one. I think it's 8. So I'm just going to, sorry, 9. So 8, 9, 10. So let's go with 9. I think generally it was the middle one. It will be the same. Once you've got it once, it'll be the same. I've got PuTTY open here on the serial option there. COM9, the speed 921,600. 8 data bits, 1 stop bit. That doesn't appear to be any parity or flow control. So we hit open. Serial COM9, yeah, have to click serial there as well, and down here, right. You know what, I'm going to save this as COM9 just to remind myself for future. COM9 Sonata. In fact, let's call it Sonata COM9, then if I do COM8 and COM10, then they'll all be grouped together, won't they? Okay, let's open. Right, so obviously we're seeing nothing. So let's check we got the right one. What we're going to do is we're just going to hit the reboot button on here. The reset button is the large round one with reset written on it. We press it. Look, there we go. Sonata system. So that's our debugging one. Sonata system. It's got the get SHA. It's got which slot, software slot we're on, because obviously, as we mentioned before, we have software slots or software app selection, and we have bitstream selection as well. So you have 3 different bitstreams, 3 different apps. Yeah. Booting the program. So that's all the bootloader. That doesn't really change much. And then this one is actually from the code. So just called LED walk raw. Look, pretty LEDs, right. And that is the simple stuff. Okay, what about code? Well, we need to go and get the code from somewhere. I downloaded it and deleted it, check it worked. So I've made my own version, but you can use the original. I just forked it and I work off my fork because I'm going to be submitting possible changes. Important to have the recurse there because we have submodules which we can show you once it's finished. Yep, okay, so we could see it in there, but we can look at it with Windows as well. Wherever that's gone. No, we'll just do that. Twink. So if we look on the Linux, Ubuntu home, because that's where we are, Alan S, that's me. I created a folder called GitHub and it's extracted CHERI RTOS into there. If we go into that and then we go into SDK and under third party, these are all submodules, Microvium and Magic Enum. So if we have a look at Microvium, yeah, you've got the Microvium stuff as well, so that's worked too. So the next thing we need to do is build things. Building isn't terribly difficult once you've remembered it, the commands. So they are very slightly different each time. So this, I should say, is running on this Docker desktop instance. Or will be. Yeah, once we open Visual Studio Code, it will be running on the Docker instance. So let's have a look. We've got CHERI RTOS. So if we change into that. Okay, the next bit is having installed it in this section here. Our next bit is we want to open that in Visual Studio. So you can see I was trying to remember the code to type. It's code and then the current dot is the current directory. Should open, albeit it's opened it on another window. I will bring it down into this window. Give me a second. Yes. Do you want to reopen in container? Yes, absolutely. Very important that we have Docker running at that point. So it's going to reopen that in the container. It's not super quick the first time. Oh, there we go. It actually has finished now. There we go. This took about 5 minutes, I think. Anyway, right, done. Press any key to continue. That's fine. Okay. So here we have the dev container, we have the SDK, we have the examples and the exercises. So examples, there's a hello world example. How do we build that? Well, you see there's a build subdirectory or subfolder there. There's a little readme file explaining it. I've got the preview on. The preview is intensely annoying at times and sometimes goes completely haywire. But for now it's working. For the markdown files there. There are Lua scripts for building for Xmake. Sorry, Visual Studio, despite having had it open several times today, decided to do an update on me. Right, so we're back in Hello World example. I've opened the terminal at the bottom. So let's go into that folder. So we can't do it through this one because this isn't in the Docker. We're doing it through this one because this terminal is in the Docker. logic. So we're in CHERIoT, we're going to examples, and then we're going into 01. Yeah, if we come in here, we do xmake, again following their examples, config. Now this particular one, we have to CHERI tools, specify the board. Yes, you don't have to do it longhand, but like the upper key is your best friend. Sonata. So we set the board, set the CHERI, the SDK, we hit enter, and away it goes. And that's so Sonata, the boards. Let me show you this. Under the SDK, down here we have a folder called boards. In the boards folder we have sonata.json. This is a symbolic link, so it's actually pointing to something else, probably. Yeah, that's why it's important to have the Sonata boards. If you have different hardwares, different versions, so that like there's Sonata 0.2, Sonata 1, and Sonata 1.1, you could go in and check what the symbolic link's pointing to. Normally it points to the latest, so it's normally pointing to 1.1 at the minute. But that's just so you know, if a new one comes out, that's how you would change it. So instead of just typing Sonata, which is this symbolic link to there, you could actually specify this particular version if you wanted to build for that. And there's other, you know, the Sail and the Ibex and the simulators and so on. So there are alternatives that also run this. I've just only ever played with it in Sonata. Right. So we go back to my hello.c. So hello.c is simple, just hello world over here. So we've done the xmake. The next one we just do is literally just xmake, which does the actual build. And this is the first time, so it's going to build and link everything. And the last command is xmake run. So you don't have to do the first one every single time. It remembers it unless you clean everything out. Right, and then it'll say, oh, copy this file across. Now, this has been changed since it was first done. So let's bring up the SDK where I left it. I went under there, but let's come back out of that. So we'll go back into those examples. So where does it actually put it? It gives us a bit of a clue. Originally it only built it for software app 1, and it called it firmware.uf2. So if we go in and have a look in this hello world, and then under build, and now we've got all these builds here. So we're looking under CHERIoT, and then CHERIoT again, and then release. And yes, there is firmware.uf2, but are there any other uf2 files? Well, there's hello world.uf2 as well there. Yeah, so you can actually have more than one. You can change the build to build for different software apps. At one point I had a previous version set up, though it would build it would call it hello world .1.uf2 and .2.uf2 and .3, so I could put it in either of the three apps because obviously they're in different places. So that last stage is what turns the yeah, so let's just go through these again to make it clear. So that sets up the configuration for it. That one actually builds it. An xmake run turns the bin file into the uf2 file that can be uploaded. So how do we use these? Yeah, let's put it over there and let's make it smaller. Right, and let's put another one over here, and we will point that at the Sonata. Yeah, nothing on there at the minute. And while we're here, we've got putty running as well from earlier. Installing is simply a case of dragging it across. Drag it across. It's going to change over there as well. Yeah. Yes, I want to use it anyway. There we go. It should automatically install it, and then this should reboot. And it hasn't. Possible that we've built for the wrong one. So we put version 1.1 on here. Let's try a different board version then. Let's try 1.1. Let's set that explicitly as version 1.1. Now we'll run xmake. And now we're on xmake run. Don't worry about that warning, by the way, that happens quite a lot. Yeah. Yeah, build, CHERIoT release, firmware UF2, and that's where we are. If we look in here, hello world, build, CHERIoT release, yeah. Firmware UF2. Let's just delete the one that's in there. Yeah. This is the classic, what happens if you use the wrong build? Yeah, copy here. There we go, and it rebuilt. So what happened with that first one that I copied across? It was probably built for the wrong system. Maybe the default compilation on this one at the minute was 0.02. I think that's fairly unlikely, but it might have been 0.1, and we put 0.11 on. So that's an important thing to show. Yeah, but once we've done that once and set the board and got the right board, each time we make a change, it's just xmake and then xmake run. Xmake gets the binary, xmake run builds the UF2 file, which we can then copy across manually. There is on the tutorial something about editing some other scripts so that it will automatically copy it across. Nobody's made that work on Windows to the best of my knowledge. And it really doesn't take much just to copy a file across anyway.